This is a pre-built version of the application. So let's go ahead and run it. And we'll have six peers that will be cooperating in trying to find a formula that uses logical operators, and we will be using genetic algorithm in order to evolve the population from one generation to the next using selection, crossover, mutation, and elitism. And this will be the first peer, second one, number 3, and number 4, 5, and 6. And each one of the peers will pick up messages coming from all others. So this is my machine name, and this is port number. For each one of the peers that we're picking up messages from. And I'm picking up messages for the same peer here for convenience, but it does its own checking, and it's not gonna pick up its own messages. Same here, etc. And we'll have those 6 truth tables. So for AND, if we have 2 true, then the AND will give us true, otherwise we end up with false. And for OR, if we have 2 false, then we end up with false, otherwise we end up with true. For XOR, if we have 2 of the same type, then we end up with false, otherwise we end up with true. And NAND is the complement of AND, so the inverse of this one. We have 3 zeros here, we end up with 3 ones here and a 0. And for NOR, it's the inverse of OR, and XNOR, it's the inverse of XOR. And we can run with data coming from code. So this data, here we have 9 events, and this is the expected result. And here we are picking up the data from the database, data.db, so this database, and we create the database with this code. And here we are picking up the data from file. So the file name is data01, this file. that has those 4 events and this expected result. So we want to produce a formula that ends up giving us the calculated result is equal to the expected result. So this one found the formula and it communicated it to all other peers. So this is username and port number, and so this is the formula in postfix notation, and this is the formula in regular notation. That would result in all those calculated results equaling the expected result. So we have a population of group of expressions. So here we have the events and the formulas. So all of this in postfix notation, and this is the expected result, and this is the calculated result for each one of those expressions. And each row has a group of expressions, and we have 8 expressions here, so we ended up with a fitness of 8, which means all the calculated results are the same as the expected results. So we start from generation 0, where the fittest group of expressions has a fitness of 6. So this is a table representation of that group of expressions, and those two do not match, and those two do not match out of 8 expressions. And we keep going, generation 1, etc. Like here we're still at 6. Until here we got to 8. So here we had 7. We only had those two do not match. So let's try this event vector, apply this formula to it. And we end up with a negative result. And maybe if we try this one. So the calculated result is positive. And the other peers, like this one, the best it could get is 7 a fitness of 7. So 7 expressions in the group of 8 expressions. So those two did not match. And when it received the discovered formula from the other peer, it stopped and displayed that one. And let's go ahead and show using the DB with the data coming from the database. Just have one peer. Here we go. So we discovered this regular notation formula, and in postfix notation it would be this one after 3 generations. And let's do the one coming from 5. And here we go. We found this formula in postfix notation and this one in regular notation after 3 generations. Here each group of expression has 4 different expressions, and we have a population of 9 group of expressions. And the source code will be available for download, and a longer and comprehensively explained version will be available for channel members, all channel members.